Well, I know a lot of this is very kind of ethereal and intellectual, but that's why you signed up. But I just kind of wanted to kind of finalize all of this, kind of squish it back into something where we've been trying to expand out of the box. You know, you get all those boxes, you're going to be using the materials, taking them out of the box to see them. Okay, it's bad fun. But I'm a dad, so I can do that, right? I want to just kind of fly through the SEPs real quick. We're going to talk a lot more in our Zoom call about this, and I'm happy to field any questions that you have about this, and as great of detail as you need. But I just kind of want to make sure that we can kind of see what these are. So these are going to be kind of the simplified versions. Is S.1A.1, ask questions. Do you see that we started with that very thing? Everything that we've talked about so far is questions. And as the teacher, not only are you going to be asking your students questions, we're really trying to get our students to ask questions. We really want them to say, how does this work? How does that relate to this over here? And we're going to be giving them a lot to do with that. Then when we look at S.1A.2 is develop and use models. Well, we're building things, we're making physical models, but whenever we graph, we're also using a form of modeling that's different. So coming up with what is a model, there's a great video on the Next Gen Science Standards, and you can kind of just Google that up. What is a model? And it kind of walks through what that is. That's a fun one to do towards the beginning of the school year to make sure that your students know that models aren't just something physical here. An equation, y is equal to mx plus b, is a model for a line. So just kind of making sure that you know that models go into a lot here. So when we're actually dealing with math and when we're actually trying to implement that in with science, we're making and using models. S.1A.3, plan and carry out investigations. Well, you're building a kit that you can take and have your students do a variety of different kind of investigations in this class. You want to be able to have them to ask a question, and having them ask a question gets them to the point to where they can come up with an investigation or a way to investigate their question itself. That might be as simple as what we're going to get to in a moment, obtaining and communicating information. If we're going to be looking at how we are going to be investigating, sometimes that's just research. It could be that simple. S.1A.4, analyze and interpret data. If you are having your students gather information because they're doing an investigation, they're going to be collecting data. Hopefully you've been taking the time to kind of collect data points about me. You should be collecting data points about your students. Your students should be collecting data points about all sorts of things. This can be done through actually doing your research, could be done doing any kind of investigative modeling, all sorts of things, measuring. This is all different tools and techniques to get you to create the data that you're going to have to analyze. So the data nugget material that we were going to be working with was going to be a kind of a great example of that. You'll have a link in here in the inside of your inside of that Google Drive link box that I'm going to have for your file folder. There's going to go ahead and be a small section in there. Normally, if you're not familiar with data nuggets, you actually have to contact them, prove that you're a teacher, and get all the answers. I've done that for you, and I actually just have that I'm going to give to you to make your life easier. S.1A.5, use mathematical and computational thinking. So this is going to be great. We're already looking at the data, but if you're kind of having to create your own data from scratch, here we go. All right, so what formula should we use? Well, I don't know. Well, okay. Now we can start involving the math teachers. Now we can start involving the research that we have to. When we're talking about the movement of spherical bodies in the cosmos, you know, that's something that we have to look at. If we're looking at the R value of how fast a virus is going to spread throughout an ecosystem, that's going to be a mathematical model that we can come up with. We can look at these things that are going to give us data points, and now you got to kind of think through that. There's a lot more mathematical models out there that your students are going to be able to use than you've probably seen, because they're not all just in your standards. But there's other stuff out there that helps enhance your standards, and that's really what I want you to kind of think about. 6.1a.6, construct explanations. Why? Well, if you can answer that question, you've just come up with an explanation. Thank you. S.1a.7, engage in scientific argument for evidence. Wait, what? Argument? You mean like debate? Yeah, we had a whole video on that. Hopefully you enjoyed those videos that my students put out too. They worked really hard on that. S.1a.8, obtain, evaluate, and communicate information. Outline. Be able to read. Look at this. Whenever you are gathering data, you are obtaining information. Whenever you are presenting your findings in front of a class, you are communicating that, evaluating the information that you gathered. That deals a lot with being able to analyze and interpret data. These are not necessarily separate standards that you're going to cover on Monday, and then on Tuesday, then on Wednesday, at the beginning of the school year, as you're trying to teach your students what the SEPs are, so we can get into the actual material of our class. This is interspersed and interwoven throughout every single piece that we do. S.1b.1, construct devices or design solutions. That airplane model that we have, we didn't have the bamboo skewers that we needed in time for us to film this video. We had to come up with a new way to attach those wings. So what we ended up using are little stirring straws for coffee and putting a piece of metal to reinforce that in there. It's just an unfolded paper clip. How can you do things like that for your students where they've got to come up with some new way? Maybe don't give them all the materials. I'm sorry, Mr. Pushkas, we don't happen to have everything that we need here. Can you make it? Can you figure out another way to accomplish the same task? This one's a real fun one for me, particularly as somebody who is additionally certified in STEAM. I love trying to incorporate this. How can I make this more artsy? Okay, if I'm going to be wanting to, after we create the models, if we're looking at ecosystems, or maybe we're talking about mating within bird species, I can look at this and maybe I'm going to glue feathers all over this. Will it still fly? There's only one way to find out. Is there a way that we can look at this, and how would we compare your glider and my glider? Maybe I've cut out a component of the tail. Now we're looking at genetics, and now we're looking at diversification of species. We're looking at adaptation. Okay, I need to get you to throw your glider from this side of the room to the other side of the room in a certain time frame. Okay, yeah, now you can only use like a slingshot, or you can only do this. I've now given you a whole new problem, and something you've already done, you now have to do in a different way. Not only is going through the SEPs like this beneficial for us as teachers, but once we start thinking outside the box and starting to think about ways we can bend our understanding a little bit and say, you know, there's a lot more here to it than meets the eye, our students are going to learn so much more. I'm really looking forward to seeing what you all come up with. I'm looking forward to speaking with you all on Zoom. Have a good one.